Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. We will continue about our lesson today. Our lesson before, for last week before, we have been discussed about classified cam and follower. Today we will discuss about the follower. In this session we will be discussing about first is type of follower. The second discussion then type of follower motion and systematic construction of displacement diagram. The third is generating of cam profile for given displacement using nav as follower and roller follower. As we know, the two kind of follower is most used in construction, machine construction, or industrial manufacture. This is another type of the follower. You can look the illustration. This follower is curvaceous follower and oscillating roller follower have oscillating motion, and then for offset follower is used for displacement only for translating or linear motion. And then the flat base follower is most used in automotive construction, like valve actuator in automotive mobile. And then the groove follower, you can look this picture. There is have a grooving in the cam, so the roller including the groove of the cam. On this lesson today, we will try to discuss about two types of the follower: this roller follower and then knife edge follower. After that, we must know about the follower motion. The follower motion have four motion. The first motion is uniform velocity motion, and then the second motion simple harmonic motion, and the third motion is uniform acceleration and retardation motion, and the last motion is cycloidal motion. For definition, we already know about from the discussing before, the last week before. Now we discussing about the kinematic diagram for its motion, especially for follower motion. After we know about the follower motion, you must know about the displacement diagram for the follower, between the follower and the cam. Displacement diagram is distance that the follower moves during one complete revolution or cycle of the cam while the follower is in contact with the cam. This is first definition about the displacement diagram. There is have two kind of the motion from cam and profile. The follower motion we can use as node for the linear displacement, and the cam motion we can note the theta symbol for angular displacement of the cam for one full rotation. In a period about the cam and follower, we know about the three kind of motion between of that. The first motion is rise or stroke. This motion is the upward motion of the follower caused by cam motion. We can say about the rise, yeah. And the second motion is dual, yeah. Dual is the stationary position of the follower caused by cam motion, yeah. This is the second motion, yeah. And the third motion is fall or return stroke, yeah. The fall is the downward motion of the follower caused by cam motion. Design about the cam and follower have three motion: rise, dual, and fall. Okay, this is the type of the uniform velocity motion, but the follower and cam design. We will discuss about the first type of the motion from the follower. Uniform velocity. A follower shows uniform velocity when the equal distance transfers by it in equal interval of time. This you can look this illustration. The motion between about the cam and follower have the uniform velocity, or the velocity is constant. You can look the illustration. This is for maximum follower lift for y-axis, and for x-axis is angle of ascent. Yeah. This represent the time, or it may represent for the cam to complete one revolution. Yeah, it may represent the angular displacement or velocity or acceleration about the follower. Yeah, this is for maximum lift, and this is of angle of action. Yeah, for angular moving or theta. For the uniform velocity, we can look for the sample. This motion is use a hot shape cam like this. Yeah, this is for sample about the uniform velocity motion cam. Yeah, since the follower move with the uniform velocity during its rise and return stroke, therefore the slope of the displacement curve must be constant. Yeah. A little consideration will show that the follower remains at rise during part of the cam rotation. The period of during which the follower remains at rest area, as we know about the dual period. Yeah. So for the illustration, the cam follower motion have the rise, dual, and the return to stroke or fall motion. Yeah. Okay, the second motion is simple harmonic motion. Yeah. This is the definition about the simple harmonic motion. When the particle move on circular path with the uniform angular velocity, its projection on the diameter will make simple harmonic motion. The displacement diagram is contrast about the semicircle. Yeah, you can draw the semicircle on the follower stroke as diameter, and then divide the semicircle into any number. Any number, even equal part. Usually use the x part or x part. Yeah. If the illustration, we can use the sig part like this. After that, divide the angular displacement or the cam during the stroke and return to stroke into the same number of equal parts. Yeah. So you can divide the angular displacement like this of the cam during the stroke. Yeah. This is for angular motion. This is for linear motion, angle of action, projection from the semicircle, and this is for maximum follower lift. Yeah. After that, the displacement diagram, projection this part into the sig part we have drawn before. Yeah. This line you can take a line for the right direction. This is for 1 point, and the second divide for the semicircle is number 2. You can take a line to the right position, and the intersection about 2 kind of line you can use the C knot, and the third part take a line to the right position, and the intersection of the number 3 you can draw the D position, and the fourth part take a line, the same take a line, and intersection to the four part the linear or angle of action. Yeah, and this is E position. And then sig part for the semicircle, you can take a line to the right and intersection to number 5. This condition same for the sig position. Yeah. After that, you can take a line to the point A, B, C, D, E, F, G. Yeah. You can make a curve like this, a smooth curve like this. This is a motion for the follower. For example, a simple harmonic motion, a type of cam and follower usually used to circular cam. Yeah, this is for example of the simple harmonic motion. And then the third motion is uniform acceleration and retardation. Yeah, rate of change velocity with respect to the time is known as acceleration and retardation. Yeah. We see that the displacement diagram consists of the parabolic curve, yeah, and may be constructed about our discuss below. Yeah. And for the first method, you can divide the angular displacement of the cam during the stroke. Yeah, you can divide, for example, for 6 part 1, 2, 3, 4, 5, 6. Yeah. After that, divide the stroke the follower into the same number of equal or even part. You can draw like this. Yeah, divide for 6 part 2. Yeah, 1, 2, 3, 4, 5, 6. Yeah. After that, join the intersection about the line like this line, but the intersection for example for line 1, I have the intersection for the angle of action 1. now you can be draw the knot like B position. And the second, for two part of number 2, the intersection of number 2 for the follower position and the cam position, angle of fashion, you can draw the 3 point here. And the 3 part of the same condition, you can have intersection about the 3 motion for follower and the cam, and you can draw the 3 knot of 3. Yeah. For part number 4, 5 and 6, you can draw from the G point, yeah, for this position. For the A point, we can call this acceleration. From the G point, we can say the retardation. Yeah. The same condition from A point, you can draw the line about the 4, 5, 6 condition. Intersection for example, for line number 4, you can draw the F point, and same condition for 5 and 6 number. After that, you can draw the line of the curve, yeah, between its point A, B, C, D, E, F, G. Yeah. This curve drawn about the uniform acceleration and retardation. Yeah. For point A, B, C, D, we can say this is acceleration point. Yeah. For D, E, F, G, this is for retardation point. Yeah. Since the acceleration and retardation are uniform, therefore the velocity varies directly with the time. Yeah. This is the sample for uniform acceleration and retardation cam. You can look the illustration below. This for the cam and this for the follower. Yeah. For this area, if we have the rotation to the clockwise, this area we can say about the acceleration. And this second motion on this area, this is for retardation motion. After that, for this area is a retardation motion, and this area is for acceleration motion. Okay, now we will discuss about the last motion. Yeah, the cycloidal motion. Yeah, the cycloid is the locus of the point on the circumference of the cycle which roll without slipping on the fixed straight line. Yeah. We know that the cycloid is curved by a point on the circle when the cycle rolls without slipping on a straight line. In case of cam, the straight line is stroke of the follower which translating, and the circumference of the rolling circle is equal to the stroke as the follower. Yeah. Okay, for the displacement diagram is obtained as the discussed below. The first method is draw the circle of the radius for this equation. The radius is equal P L is a follower leaf, divide 2 ya, half P multiplied L is the follower leaf ya. The second method, divide the circle into any number of equal even part ya. Now we can look this illustration. This is have a 6 part ya. Project this point horizontally on the vertical center line like this ya. And then divide the angular displacement of the cam during the stroke into the same number of equal even part the circle like this ya. The same part ya, 6 part like this ya. Draw the vertical line like this ya. So we have 6 part on the circle and 6 part on the vertical line for the cam motion ya. Okay, you can look the illustration for the circle and the linear motion or 6 part. For the circle, you can look the 6 point ya, 1, 2, 3, 4, 5, 6 ya. After that, draw the line between A point to G point. This line is center of the circle. Intersection to the line of center of the cam motion. The point of 3. Intersection for this center line and the point 3. You can draw the knot about D point like this ya. After that, you can track the line in this point. This point is center for the part 4 and 5 point ya. You can straight line, straight line like this, equal to the first line. And then this line intersection to 4 and 5 point ya. 4 and 5 point ya. The intersection about the 4 point, you can draw the E knot, and the 5 intersection 5 point intersection to the line F notation ya, like this. So you can look the illustration. You have A, D, E, F, G point ya. And the last line, take the straight line, this point ya. This point is center to 1 and 2 part ya. Take the line equal to the line for center line like this. Intersection about point 1 in the circle and point 1 the cam and the cam motion. You can take the B knot ya. And the point 2 on the circle, intersection to the point 2 in the cam motion. You can draw the C point like this. And now you have a 6 point ya. A, B, C, D, E, F, G. After that, you can draw the curve between this point like this. This is for the cycloidal motion ya. This design to make a motion without slipping, yeah, between the cam and the follower, yeah. Okay, furthermore for the lesson, you can look the problem examples below. This is the question: design a cam with following dimension, yeah. For angle of action, for the rise motion, we have 150 degree, yeah. And the angle of dwell is 40 degree, and angle of descent or the fall is 60 degree, yeah. Dwell of the rest of the cycle, and then for a maximum follower lift, this maximum follower lift we have 30 millimeter, yeah. And this sampling problem use the knife edge follower, yeah. The rest of the follower use the simple harmonic motion, and the fall use the uniform velocity, yeah. Now you can draw the design of cam with this dimension, yeah. Okay, this is the answer. First, you draw the simple harmonic motion for rise motion, yeah. This is have a 150 degree angle of action for rise motion. You draw the semicircle and divide the semicircle with the sig part, and divide the cam motion with sig part 2. For the first part, you can strike a line to the right and connecting the number 1 to the cam motion. This is for the first point, yeah. This point B, yeah. This point A is the began for semicircle. Is the start point. B is intersection for the first part between the semicircle part and cam motion part, yeah. And the second, you strike a line to the right for a 2 point, and intersection to number 2 part for the cam motion. Intersection, you can draw the C point, and the number 3 part for the semicircle, strike a line to the 3 part for the cam, and you have the D point. This is also same for the 5, for the 4, 5 and 6 part, yeah, between the semicircle and the motion cam, yeah. After that you have A, B, C, D, E, F, G point. You can draw the curve, yeah, between each point, yeah, like this. This is the follower displacement motion, yeah, for the simple harmonic motion. And then the second method, the second motion is dwell. For the problem example, the dwell have the 40 degree. 40 degree. The dwell is stationary, yeah, for point G and H, yeah. This is for a lift maximum about the follower, yeah. And the last condition is fall. The fall motion use the uniform velocity. You can define the angle for the fall is 60 degree. You can divide for 6 part, like this. Because the fall motion is uniform velocity, the point have the same velocity, and you can draw the linear line like this, between S and until end point. This is a motion for displacement follower. Displacement about the follower. After we draw the displacement from the follower, you can draw the cam profile, with the degree from the problem sample. The rise angle of action have the 150 degree, and the dual motion or stationary have a 40 degree, and the last motion about the fall motion have the 60 degree. This is for rise, dual, and fall motion. We can try the cam profile with the nav edge follower. We can look the illustration. This is a nav edge follower, and then you can draw the cam profile like this. Divide the X part same with the follower displacement like this. After that, you draw this line, the S point projection from the displacement of the follower. For example, for the first point, it's point B. You measure the length as point B and projection to this length. The second condition with the point C, this length, projection to this length, and the three lengths for point D, you can draw with the projection this length. The second condition with the point 4, 5, and 6. This line is projection from this line. 4, 5, and 6 lines. And then you can look the picture. We have the projection line from the follower displacement to the cam profile. This area is for rise motion, for the rise motion. After that, you can draw the dual motion. Dual motion have a length same with the 6 displacement the follower. 6 and 7 have the same length. So you can draw the curve about the cam profile like this. After the dual motion, you can draw the fall motion. Use a uniform velocity. Projection the point S until the end point. This length, and this length, this on length is projection to the cam profile. 7, 8, 9, 10, 11, 12, and 13. This line is projection from the follower displacement lines. After that, you can draw the line with the curve between the each point, and then you can look the result for the cam profile like this for the problem example. This cam profile for the knife edge follower type. How about the roller type of follower? This problem same with the knife edge. The difference only on the roller dimension. You can increase the roller dimension. This projection, the all projection dimension, you must increase the radius for the follower, and then the result is the cam profile for follower is also same with the knife edge follower. The difference only on the dimension, increase dimension from radius the follower, roller type follower, like this.
Hello friends, so next question on cam and follower is having flat face follower with radial position. So first we'll draw a base circle having radius RC, after then vertical line passing through center points and the flat face follower. Now we'll divide this base circle in different angles like phi A, delta 1, phi D and delta 2, and we'll divide this angle of ascent in 8 equal parts from 0 to 8. After then we'll draw lines start from center points passing through each points, and we'll mark the displacement points on each line. And next we'll draw face of the follower on each points, and the final cam profile will be tangent to all face. So this is the cam profile. Like this we will complete this numerical. So the numerical is a flat face follower is operated by a uniformly rotating cam. The follower races through a distance of 25 mm. So h is equal to 25 mm and phi A is 120 degree and delta 1 30 degree. And phi D is given as 120 degree and delta 2 is 90 degree. And follower rise with cycloidal motion, and the follower return with uniform acceleration and deceleration. And the least radius of the cam is given as 25 mm, which rotates at 300 rpm. So we can say speed of the cam is given as n is equal to 300 rpm. So the final we have to draw a cam profile and determine the values of maximum velocity and acceleration during rising. So we can say omega is 2 pi n by 60, so simply 31.4 radian per second. Now we'll draw follower displacement diagram. So first we will make a box, rectangle box, and in this horizontally we'll take phi A, and in vertical side we will take a displacement h. We'll go for actual dimension of displacement, that is 25 mm, but at horizontal side we have phi A, that is angle of ascent, so that is 120 degrees. So we'll take a suitable scale and we'll divide this phi A in 8 equal parts. After then we will draw a diagonal and we'll draw a circle having radius h by 2 pi. So in this we'll draw parallel lines of the diagonal like this, from 2, 1, 3, 1 points, 0, 8, 4, 1 points, 5, 7, 1 point, 6, 1 point. So total 5 lines we will draw parallel to the diagonal. And now we will mark from 0, 0 dash, 1, 1 dash, 2, 2, 2 dash, 3, 3, 3 dash, 4 dash, 5 dash, 6 dash, 8, 7 dash and 8 dash. Like this we will complete this follower displacement diagram when the follower rise with cycloidal motion, and in this is the final displacement curve for cycloidal motion. Next is 30 degree 12. So we'll make a rectangle box and we'll draw what horizontal line. Next we'll make a uniform acceleration and deceleration. So in this we will make this vertical rectangle box, and in this we will divide this phi D in 6 equal parts, and also the center line we will divide in 6 equal parts. Now we'll draw a diagonal like this, and we'll draw lines like this. Now we'll mark the points 6, 6 dash, 5, 5 dash, 4, 4 dash, 3, 3 dash, 2, 2 dash, 1, 1 dash, 0, 0 dash. and this is final displacement curve when the motion is uniform acceleration and deceleration, and this is the second dual, that is angle 90 degree. So that is displacement diagram, and now we will draw cam profile. Now first we'll draw base circle, and we'll divide this base circle in different angles, phi a, delta 1, phi d, and delta 2, like this. Now we'll divide this phi a in 8 equal parts, and also in phi d we'll divide this in 6 equal parts. After then, as the position is radial, so we'll draw lines start from the center points passing through the points, like this. Same for phi d also. Next we'll mark the displacements on each line from 0 dash to 8 dash and from 6 dash to 0 dash, like this, and we'll draw face of the follower normal to each line, like this, for phi a and phi d, and the final cam profile will be tangent to each face. So we can say this is the final cam profile. Now this is the final cam profile, and we have to find out the maximum velocity and acceleration during ascent. So we have motion is cycloidal motion, so maximum velocity is 750 mm per second, and maximum acceleration is this 35,310.
Okay, that's all for our lesson today. If any question, don't hesitate to ask me. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.